Hey y'all, this lesson is on the p-value approach to hypothesis testing. So my last video, I talked about the critical value approach, and basically those are two approaches to come to the same conclusion. So once you learn both of them, then you can decide which one you like better or you understand better and pick one and do that. I personally prefer the p-value approach because, well, first of all, I understood it better when I was learning it, and when I was looking at statistical studies and reading research articles, I felt like the p-value approach was used more often, and so it was more valuable for me to know that approach. But you get to choose which one you like best when you are making decisions about hypothesis testing and use that. So I like the versatility of it. The p-value approach focuses on areas under the normal curve rather than z-scores. So we use a z-score to find the area, but then we use the area and the significance level to make a decision. So for a p-value approach, we're finding how likely the observation value used for the test statistic is, assuming that the null hypothesis is true. And when we're looking at how likely something is, we're actually looking at the probability of getting sample data supportive of the alternative hypothesis and inconsistent with the null. This means that if we were testing a value, so a test statistic, and we found the z-score for that value, and then we found the area under the curve based on the z-score. What we're finding is the probability of that value happening if the null is true. And so the smaller the probability is, then the stronger the evidence is against the null. So the closer the probability or the p-value gets to 0, the more evidence we have against the null, because we're saying that if the null is true and we get a p-value of like 0.000001 or something like that, then we're saying that the probability of getting this value based on that null hypothesis is really, really small, which means that we might need to reject that the null hypothesis is true. So if we can find evidence against the null, then we can reject the null. If the p-value is less than or equal to the stated alpha level or significance level, then we reject the null. And you might see the wording like this. I'm going to insert the example where we had like a bag of chips. So if it were true that the population mean of the weight of a bag of chips were equal to, I think I said like 0.5, and the sampling process were performed repeatedly, the probability of getting a value less than 0.5 is some number, 0.08 or something. So we're saying if it were true that this, then the probability of getting an alternative is p-value. So we're finding the probability of something happening. We have, it's in this one, we're given the test statistic. So you may be asked to find the test statistic. The test statistic is a z-score in this case. And remember, we find the z-score by doing x minus the mean over the standard deviation. So you may have to find that first, but in this case, it was given to us. So we're looking to find the p-value based on the z-score. And remember that the areas in the table represent the area to the left. Now this is a right-tailed test. So we're going to use that area to the left to help us find the area to the right. We're looking at 2.84. Here's 2.8 over to 4. I'm going to circle that. That's the area to the left. So the area to the right would be 0.0023. That's our p-value, which doesn't really tell us anything yet, but we are going to use it to help us make a decision. Or if you don't have a z-table, you can use your calculator, and in your calculator you can input what region you're looking for. It is a right-tailed test, and the z-score is 2.84. So we're looking for this area, which means that we're going from 2.84 to infinity. This is standardized, so I did not have to put 0 and 1, but if you want to, you can. And when you input that into your calculator, we have normal CDF. You'll go to second vars and go to normal CDF because we're looking for the area under the curve. 2.84, comma, infinity, which we'll just use a really big number. And you can't see the value, so I will zoom out really quick. Here you go, 0.0023 if we round. So get the same thing on the calculator. The difference with the calculator is we don't have to consider, oh, is this the left area or the right area? We get to just tell it what area we want. So we got a p-value of 0.0023. Now, like I said, the p-value doesn't tell us anything. We can't make a decision yet. We can only make a decision when we know the significance level. So in the next part of the question, at the 1% significance level, do the data provide sufficient evidence to reject the null hypothesis in favor of the alternative? So what we're looking at here is an area. And if you remember the picture of the rejection and non-rejection zones, we have, this is a right-tailed test, told us that at the beginning. And I'm going to call this alpha equals 0.01. So that piece that I shaded in on the right side is representing an area of 1% or 0.01. Now, if the area of the p-value is bigger than this area, then that throws it in the non-rejection region. If that area is smaller than my significance level, then that throws it in the rejection zone. So this zone, region, whatever, is non-reject. And we have a p-value of 0.0023, which is pretty small. 0.0023 is an area over here. Since our p-value is in the rejection zone, p is less than alpha, then we would say we can reject the null. We have statistically significant evidence to reject the null in favor of the alternative hypothesis. So the test results were statistically significant. This means that for this problem, there would be some sort of mean, and we're claiming with 99% confidence that the population mean is within a certain range. And basically we're saying that if it's outside of that range, then we have reason to reject the null. And in this case, we found some value in our data set, or we found some, we did some sampling process, maybe a sampling distribution, and we found a mean, and that mean was out here. It gave us a z-score. We found a value, sorry. We used a value, found the z-score, not a mean. We found the z-score, could have been a mean. Anyway, we found a value, found the z-score, and it put us out here in the rejection region outside of our confidence level. And that means that we have enough evidence to reject the null. Moving on. That got confusing with the z-score thing. All right, the value of the test statistic for a two-tailed z-test is negative 1.72. Now remember, if it's two-tailed, then we have negative 1.72 over here, rejection region, and positive 1.72 over here, rejection region. And I'm looking to see what this area is so that I know my p-value, that probability. So I go to negative 1.72, 1.72, and we get 0.0427. Now, I've only found one side. So I also need to consider this side. For a total area of 0.0427 times 2, 0.0854. And then for your calculator, you have to consider the same thing. If you type in your calculator only one side, then you have to remember that it's two-tailed and there's two of those. And so in this one, we do times 2 at the end, or you can hit enter and do times 2. Now keep in mind here, this little negative goes with that. It just kind of went over to the previous line. If you type that in, you should get a p-value of 0.0854. Now again, we cannot make any conclusions at this point because I don't know the significance level. It may be 1%, 2%, 5%, 10%, we're not sure. So we'll go down a little bit further and we have to see what the significance level is. In this problem, it is 5%. So we've got our little curve. Oh, that's terrible. 5% is split up into 0.025 on each side. And we got 0.0427, which is actually, this is a horrible sketch, but it's not an accurate percentage. I'm just sketching it. So 0.0427 is actually outside of our rejection zone. So we got a p-value greater than alpha, which means we do not reject the null. We have sufficient evidence that we cannot reject the null hypothesis. The probability of getting this value, whatever it was that we're testing, is about 9%. And compared to a 5% significance level, that means that it's not statistically significant. It's within our non-rejection zone. So that means that our estimation for our population mean is plausible because it's in here. Okay. Then I have a couple down here where we don't have right-tailed or left-tailed because it doesn't really actually matter whether it's right-tailed or left-tailed or two-tailed. I mean, it does, but when you're comparing a p-value to an alpha value, you don't have to know which tail it is. We're just comparing values. So if p is less than or equal to alpha, then we reject, because it puts it in that rejection region wherever that is. Could be two-tailed or one-tailed, but in either case, if your p-value is smaller, you're saying the probability of getting this value is smaller than our significance level, then that puts it in the rejection region. So the p-value for this one is 0.07, and you're going to make a decision on each of these significance levels as to whether you reject or not. So go ahead and pause it and try it, and then come back and check your answers. On the first one, you should get, if you wanted to draw a picture, you could. It kind of helps a little bit. I'm just going to pretend that it is, whoa, right-tailed. Oh, it's so bad. How could you be so bad at this? I draw like 100 a day. Okay, good enough. Our alpha level is 0.05, and our p-value is 0.07, which is actually past an area of 0.05. So that puts it in this was the reject, and this was the non-reject. Whoops. So we actually do not reject the null because P is greater than alpha. Our probability, whatever the test statistic was, the probability of getting that was outside of our rejection region. What about at a 0.10 alpha level, a 10%? So 90% confidence interval. Got our curve. We've got 0.10. 0.07 is smaller. So it is firmly in our rejection region. So we reject the null because P is less than alpha. 0.07 is less than 0.10. Last one. We have our curve. Please draw a good one. Yay! And our alpha is 0.07. And our p-value is 0.07. Since it is less than or equal to, it still is in our rejection region. So we reject the null because P is less than or equal to alpha. That is all I have for this lesson. I hope you enjoyed it. Hopefully the pictures help you visualize what's happening. If you have any questions, please let me know and I would be happy to help. Bye, y'all.